All right, in our last day here of notes, we're just going to do some more examples with the chain rule. So differentiate each function. So we have y equals cosine squared of 1 minus 2x. So we see those parentheses. That's a really good indicator that we're going to use the chain rule. But I also want to look a little bit closer at this one because cosine squared of 1 minus 2x really means the cosine of 1 minus 2x all squared. So I use brackets. You could certainly use parentheses, but I see two sets of them, right? I have a line inside a cosine curve, and I have a cosine curve inside a squared or inside a parabola. So that means we need to use the chain rule 2 times. Remember, we start on the outside. So dy dx equals the 2 comes down, right? That's what's on the outside. That's my big set of parentheses. The 2 comes down, subtract 1 from the exponent. I don't know why I just wrote the 1, but I did. The inside, which is the cosine of 1 minus 2x, stays the same. So I just took care of the 2. So maybe you kind of imagine that those brackets are now gone. The chain rule says multiply by the derivative of the inside. Well, this is what was inside. Inside is a chain rule itself because I've got more parentheses. What's on the outside? The cosine. The derivative of cosine is negative sine. The inside stays the same. So I just took care of cosine. Notice we're doing one thing at a time. And then the last thing I need to do is multiply by the derivative of what's left, and the derivative of the inside is negative 2. So chain rule, 2 chains, 2 steps. You know, we don't have to do anything here to clean this up. I am going to combine what I think are the obvious things. I have a negative times a negative. I have a 2 times a 2. So I have a positive 4. I don't need parentheses here anymore because it's just to the first power. So I really have the cosine of 1 minus 2x times the sine of 1 minus 2x. So to me, those are the obvious simplifications. I didn't even really simplify much, but at least I put my constants together. Okay. Good. Let's look at the next one. I guess I could have left us a little more room. We have f of x equals the tangent of the sine of x squared. Honestly, maybe we could have done this one first because it's a little more, you know, it was right there in front of us that we had 2 sets of parentheses. It's already set up for us to look at this as 2 chain rules. So here we go. F prime of x equals, on the very outside is the tangent. The derivative of tangent is secant squared. But the inside, which is the sine of x squared, stays the same. So the tangent of the sine of x squared becomes secant squared of the sine of x squared. All right, so we just took care of that. I crossed it off. Now what's on the outside is a sine. The derivative of sine is cosine. The inside of the sine was an x squared, so the inside of the cosine will also be x squared. So we just took care of the sine. And now we need to multiply by the derivative of the very inside, which is 2x. Honestly, there's really nothing to simplify here. You could move your 2x in front, and when I type my answers, I will always put smaller stuff like that in the front, but it doesn't combine with anything, so I'm just going to leave that one alone. Okay. All right. Let's take a look at this one. We've got s of t equals the quotient of 5t all over the square root of t cubed plus 1. So we've got a couple of things going on. One, we have a quotient, right? So we could use the quotient rule. We also have a cubic inside a square root. So we also kind of have a chain rule thing going on in the denominator. Okay. So if you would like to, you may write this as 5t over t cubed plus 1 to the 1/2 and use the quotient rule. Making sure I didn't have that out of the screen there. Or You could write this as 5t times t cubed plus 1 to the negative 1/2. And you could use the product rule. It is certainly your choice. Absolutely your choice. So if I'm honest with you, I'm going to use the quotient rule, and we'll talk about why, but one of the reasons is because the first thing I do in the quotient rule is to square the bottom, so that's just me. But again, your choice. So here we go. S prime of t equals, I'm going to use the quotient rule. Square the bottom. So when I square the bottom, I'm left with t cubed plus 1. Then we rewrite the bottom, which is t cubed plus 1 to the 1/2. We multiply that by the derivative of the top, which is just 5. Minus the top, which is 5t, times the derivative of the bottom. And this is where the chain rule comes in, right here. That 1/2 comes down in front. I subtract 1 from the exponent. The inside is still t cubed plus 1. My fraction bar wasn't long enough. So I've just started taking the derivative, but now I need to multiply by the derivative of the inside, which is 3t squared. Ooh. And I'm going to be honest, there's not a whole lot I would do with this besides combine some constants perhaps. So I'd probably combine my 5 with my 3 and my 1/2, and my t's I would multiply together. But other than that, I wouldn't do a whole lot. In fact, I'm going to leave this one as is, because for me right now, I want us to practice taking derivatives. All right. Let's do the next one. R of theta equals secant squared of negative theta. Well, we already talked about this at the beginning. Secant squared of negative theta means the secant of negative theta all squared. We absolutely want to rewrite this, or we are going to make mistakes. There's my biggest set of parentheses. I mean, I use brackets, but we get the idea. So r prime of theta equals, we start on the outside. The outside is squared, so it's 2 times blank to the first. The blank is the secant of negative theta. That took care of my 2. We are going to multiply that by the derivative of the inside. On the inside is another chain, isn't it? It's the secant of, you hear the word of, secant of negative theta. So we start with secant. The derivative of secant is secant blank tangent blank. What was inside? A negative theta. So we just took care of the secant. The last thing we haven't touched is the very inside, and the derivative of the very inside is -1. Not much to do here. If I were going to simplify this, I'd put my 2 and my -1 together to get a -2. I have a secant of negative theta and another secant of negative theta, so how about secant squared of negative theta times tangent of negative theta? I mean, it looks a little bit nicer, right? Good. All right. Let's look at this one. The second derivative of x, second derivative of y with respect to x, right? Take the second derivative. So maybe we'll start like this. Y prime equals 3x squared plus 2 cubed. And they want the second derivative. Well, we see our parentheses, right? We start on the outside. We bring that 3 down in front. We subtract 1 from the exponent. And the inside stays 3x squared plus 2. So we just took care of the 3. The chain rule says multiply by the derivative of the inside, which is 6x. I didn't need parentheses there because the plus 2, well, it went away. Great. Before I take the derivative again, I am going to combine, at the very least, what I can, the 6x and the 3. I'm going to call that 18x. And then I have my 3x squared plus 2 quantity squared. So there's my first derivative, right? And I'm just going to write simplify. Anytime you need to take a derivative again and again and again, definitely simplify before you move on. All right, so what we have now is a product of two functions, don't we? We have variables here, we have variables here. I don't necessarily want to FOIL this out and distribute an 18x. We could, you could, but I'm going to use the product rule. Or FOIL and multiply out. That's your choice. I think the product rule is going to be a bit faster. All right, so y double prime equals, I've got the first, which is 18x. Then I need to take the derivative of the second, which is a chain rule. So the 2 comes down in front, subtract 1 from the exponent. The inside stays the same. And then we need to multiply by the derivative of the inside, which is 6x. Plus the second, which is that 3x squared plus 2, quantity squared, times the derivative of the first, which is just 18. Okay, so we use the chain rule to take the derivative once.
Attention staff, if you have not turned in the Chromebooks from last period, please do so ASAP. Thank you.
It's the problem with making videos after school. So we used the chain rule to take the first derivative, cleaned it up, then realized we needed to use the product rule to take the second derivative. Now, we can leave this alone. I'm going to clean it up. When you look at these two terms, they both have a 3x squared plus 2, and they both have an 18. So I'm just going to clean it up. I'm going to take out an 18 and a 3x squared plus 2, which will leave me with a 12x squared plus the 18 is gone, one of these is gone, and I'm left with an extra 3x squared plus 2. So honestly, I kind of like that. I think that looks pretty nice. So I've got 18 times 3x squared plus 2 times 15x squared plus 2. Now, it can't get much nicer than that. But again, this could have been okay, right? This is just the simplified version without multiplying everything out, okay? All right. This is a challenge. If you would like to try the challenge, pause, do the challenge, that's up to you. I will come back to it at the end of the video. So if you'd like to pause and do it now, or if you'd just like to wait, but I will do this at the very end, okay? Well, let's flip our notes over. All right, last two questions. And this table was a little bit blurry, but this is a numeric example. We've seen these before. It says functions f and g are differentiable functions. Values of these functions and their derivatives at selected values of x are shown in the table below. The first question would like us to evaluate the derivative of g of f of x when x equals 3. So we want to take the derivative and plug in a -3 for x. All right, well, this is a chain rule, right? This is kind of the definition that we have. G of f of x. So we'll start on the outside. We have g prime of f of x. The inside stays the same. And then we multiply by the derivative, which is f prime of x. Right, so I already took the derivative, so I'm not copying that down, but now I'm just going to do this to kind of notate to myself that I want to plug in a -3. By the way, there's some blank slides here. I just was leaving those there for extra room. No, we didn't need boxes there. Let's go plug in our -3. So I have g prime of f of -3 times f prime of -3. All right, let's go plug some things in or find some values. Remember, we start on the inside. F of -3 from the table, f at -3 is 2. So it's g prime of 2 And then I have f prime of negative 3. F prime of negative 3 is negative 1/4. All right, so we're not done yet. We still need to find g prime of 2. So here's g prime. Here's x equals 2. So we have 2/3 times negative 1/4, which is negative 1/6. Okay. So one place to notice, this right here is where I see a lot of mistakes. This right here does not say g prime of negative 3 times f of negative 3. There's no multiplication there. It's a composition. So we find the inside value and plug that into our other one. So be very careful there. Okay. All right, let's take a look at the last one here. Take the derivative of this lovely function when x equals 2. All right, so let's start with the derivative. I've got x squared plus g of x, all of that to the 1/2. So the chain rule says bring that 1/2 down in front, subtract 1 from the exponent. The inside stays the same. Took care of that. Now we need to multiply by the derivative of the inside. The inside has 2 terms, so we better make sure we multiply by that whole thing. So the derivative is 2x plus g prime of x. We want to evaluate that when x equals 2. All right, so let's go plug in a 2 for every x. So I have 1/2 of 2 squared plus g of 2, all of that to the negative 1/2, times 2 times 2 plus g prime of 2. All right, let's go find some values in the table here. So I've got 1/2 of 4 plus g of 2 from the table. G of 2 is 1. And this is 4 plus g prime of 2. From the table, g prime at 2 is 2/3. So what do we have here? We've got on the top, we've got a 4 plus 2/3. And on the bottom, we've got a 2 radical 5. It's not great looking, it's not horrible. What if I multiply the top and bottom by 3 to clear out that fraction? And that gets me 12 plus 2 over 6 radical 5. Now, you want to rationalize that, that's your decision. I just wanted to get rid of the fraction within the fraction. And there it is. Well, we could reduce that even farther. Obviously, we can, you know, call that 7 over 3 radical 5. Okay? All right. I'm going to go back to the challenge. If you would like to stop, great. If you want to go back, if your interest has been piqued by the challenge question, feel free to join us or pause, whatever you'd like to do. I'm going to go back and do this one. All right, here we go. Challenge question. I encourage you to try this one on your own just to see why it might be considered a challenge. So we've got lots of parentheses already. I see 2 sets of parentheses telling me chain rule twice. However, this little sine squared little thing in there tells me we probably need to rewrite this. So we've got in the parentheses x plus sine squared of 7x means the sine of 7x squared, right? I'm adding x to that, and I'm cubing the whole thing. I'm going to use some red parentheses so you see that a little better. Okay, so inside the red parentheses, it's x plus sine squared of 7x. All right, here we go. Starting on the very outside, we've got that exponent of the 3. So we've got 3 times blank to the second. The power rule says bring the 3 down, subtract 1 from the exponent. The inside stays the same. Now when I go to write the inside, I'm probably going to put that 2 back in there. So I have x plus sine squared of 7x. Great. That took care of that little guy there. We need to multiply by the derivative of the inside. The derivative, I'm sorry, the inside has two terms, so we better make sure we use parentheses. The derivative of the first term is 1, and we need to go take the derivative of the second term, which is going to go in here. And by the way, I'm not going to close my brackets until I'm done taking the derivative of this thing here. All right, on the very outside of the brackets is a 2. So I bring the 2 down in front, leave the sign of 7x alone, subtract 1 from the exponent. That took, so far I've taken care of this and this. Now, we've got the sine of 7x. The derivative of that is the cosine of 7x. Oh man. And then I need to multiply that by 7. And then I need to close my brackets. I was a little premature in my bracket closing. Wish I had some white out. And I'm sorry that got to be a mess. I'm going to rewrite this just so that we make sure we're okay, because parentheses are a huge deal here. So I've got 3 times x plus sine squared of 7x squared. In my brackets, I've got 1 plus the 2 and the 7 becomes a 14, and I've got the sine of 7x times the cosine of 7x. So that's a little bit, hopefully, a little bit clearer for you.